set has no duplicates?
Exactly. A set cannot have duplicate values. So all relational models or all our relations are a set of tuples. That means that no two tuples can be the same value. Every tuple is unique. Another difference between traditional SQL tables and the general relational framework is that traditional SQL tables might allow duplicate values. That goes into play in certain situations where SQL implementation does not want, because it requires you to go through all the entries and figure out if they are duplicates, right? So a SQL implementation would be required to go through those instances and figure out if they are duplicates and remove them. And if we are working on SQL implementations that actually work on smaller data sets or are designed for efficiency, they actually look over this particular aspect of relational models. So in general, SQL tables are multi-sets, sometimes called bags, and they might not actually be sets. But the traditional framework of relation models is that we have a set of tuples. Now, another statement that we can make for that is if two tuples T1 and T2 have the same values for all attributes, then T1 and T2 are the same tuple, i.e. T1 equals T2. Now, this statement is invalid. Okay, we have to understand why, and this particular statement is from our book that we were talking about, the database management concepts, sorry, database system concepts. But we have to be formal, and this particular statement is a bit vague. This statement means that there might be two tuples with the same values, and those two tuples are then considered the same. But that is not the case. Formally speaking, if two tuples formally speaking, two tuples can only be same if and only if they are referencing the same tuple. Otherwise, they cannot be same. So we need to be clear in our communication as to what we mean and what different terminologies mean when we are talking about these database management systems, right? And other thing, the orders of tuples in a relation does not matter. They are not relevant. If you query a particular database, you can get your values or your tuples in different orders. There can be 5 different implementations of SQL database DBMSs, and they can each process your data in different ways, getting you different values. Now, for those of you who have taken SQL, you can say, yes, I can order my databases as well, and then the order matters. But apart from that, in general, your database tuples will not have any particular order, and they will not have duplicate values. And that also becomes interesting when, let's say that you're querying a particular database and you want to look at a particular subset of attributes from a database, then your database can end up giving you a number of rows that is different from the actual database. So for example, let's say that I want all the branch names of a particular bank given that account relation that we talked about. In that sense, in that scenario, the number of branch names will be much smaller than the entire account table that we had. So the resultant table would be much smaller, right? So because it's a set and we won't have duplicate values. Okay, any questions so far? Okay. So we talked about relations, we talked about tuples, we talked about records. Now we are going to talk about schemas. Schemas are essentially, if you have worked with C++ structures or classes, schemas are essentially the list of variables and their types for a particular class. So a schema in a database specifies the type of information that a relation holds. Multiple relations can have the same schema. So I can have multiple classes that have the same structure. I can just name them differently. So similar to that, multiple relations can have the same schema. A relation schema is basically comprised of two things: a set of ordered set of attributes and the domain of those individual attributes, right? So what are the names of my attributes and what are the types of those attributes? Basically, those two things. For naming conventions. So usually relations are named or always written as lowercase letters. Again, you can change them, but for this class, we will be working with relations that will always have lowercase letters, and a relation schema is always going to be capitalized. So the first letter of that will be capitalized. So we can say that a relation R, that is a table R in that sequence, that is the account data table, and relation schema R share the relationship such that R in parenthesis capital R means that the schema for the table R is R, the capital R, right? Okay, so if that wasn't confusing enough, this would actually clear things up a bit. So this was our account relation, and this is our account schema. So account schema basically states the attributes that we have, that is account ID, branch name, and balance. And as we said in the previous slide, lowercase r in parenthesis capital R basically says the account table has the schema account schema, where it is capitalized, right? The schema is capitalized. So this just means that the account table follows this particular schema. Okay, so in general, for our class, all of the schemas will be provided to you upfront, so you don't have to work with them in our class that much. However, it is a good thing to know if in case you're designing your own database, right? Another thing to note is there is an important information missing from the schema information. So if we say account schema, account ID, branch name, balance, can someone tell me what information is missing from this schema, and would we have required some more information to explain this database or explain this table better? Any guesses? So domains are not stated explicitly in our notation. So what do we mean by domains? The type of the data that a particular attribute has. So branch name is going to be a string of legitimate branch strings. Balance has to be a non-negative value. But those things are not represented clearly in this particular formulation that we have in terms of schemas, right? However, this is a bit simpler, and this is what the relational model uses. And so this is what we will use as well, right? Okay. Now, relation schemas are basically ordered set of attributes, as we said. So if they are sets, that also means that we can actually use set operations on them, right? So what does it mean? So we can have relations R, capital R. That means that R is a relation that is a member of this particular schema, capital R. And S is a table, or S is a relation that is a member of this particular schema, capital S. So relation R has a schema R, relation S has a schema S. Remember, the schema is just a blueprint of your database. The actual table is your lowercase r or your lowercase s, right? However, the capital R and capital S contains all your attributes for that particular database, right? So if these are sets of attributes, we can also perform set operations on these attributes as well. So R intersection S, I guess everyone knows what an intersection is. So R intersection S is basically the set of attributes that R and S have in common. So all the set of attributes that exist in both the schema R and the schema S will be in this R intersection S schema. R differences or R minus S is the set of attributes that R has, but it is not also in S. So if you look at the Venn diagram, I can draw, I guess. I have this Venn diagram, I have this is a Venn diagram. So this, let's say this one is R, this one is S. Then R intersection S would be, R intersection S is this, that is common to both of those schemas. R minus S, where the smaller one is R, the larger one is S. The R minus S are all the attributes that are part of R, but not part of S. So this part is not in R minus S, right? Okay. We also have subsets of attributes. So K is a subset of R. That means that K is some subset of attributes in the relation schema R, right? So that would mean that in the account schema, that we were talking about. K could be the sets of attributes, branch name and balance. That would be a subset of R. Okay. One other thing that we should take note of is all of these are ordered sets, right? So when we say R minus S, so give me all the attributes that are in R but not also in S. The resultant set of attributes will also have the same order as they are in R. Right now, it might not make that much sense, but this is a really nice property to have later down the line. Okay. Any questions so far? Yes. Any questions?
Sorry. Uh, can you go back to the last two slides?
Last two slides, this one?
Yeah, yeah. So I thought attribute is a row of the highlighted stuff.
Yes.
Where is account coming from?
Okay, so attribute is basically, you can think of an attribute as the row, sorry, attribute is the column, not the row, my bad, I heard you incorrect. So attribute is the column of data. So if I go back, so attribute is the column of data that we are talking about. So essentially account ID, branch name and balance are all attributes of your table, right? Now, individual tables have records, right? So individual records are A301, New York 350. These three attribute values together make up a tuple, right? So individual rows are called tuples. All of these tuples together make up a relation or
Oh,
a table,
okay.
right? So account is a relation or a table. And when we are talking about schemas, we are saying that the account table follows this schema. With the schema basically explains what are the different attributes of this particular table.
Okay.
Just the names of those attributes. Make
Okay.
sense? Okay.
Yes. Thank you.
Yes. No, it is very important to actually, I actually, okay. It is really important to actually distinguish between the different terms when we are talking about databases and the different things that we are going to talk about. So, any other questions? Anybody? No? Cool. Okay. So, another thing, attribute domains or attributes need to be atomic. Now, what do I mean with that? So atomic means that if I want to change a value of a particular attribute, that is, I want to change within a tuple, I want to change the value of a particular attribute, I will not be allowed to change part of that attribute. I will be changing the entirety of that attribute or nothing at all. An example for that would be, let's say that we have an attribute for the date an account is created. I should not be allowed to just change the month of that date. Instead, I would be required to change that entire date. So that is what we mean when we say that attribute domains are atomic. So atomic means we cannot